Hi students, good evening. Welcome to this video session. My name is Samuel Dominic Chukwu Emeka, aka Sam Dom for Peace. In this video session, we shall discuss the section 5.4 homework assignment. Section 5.4 homework assignment deals with calculating the parameters of a binomial distribution. It is recommended that you view the videos and read the notes on the binomial distribution probability prior to viewing this video. In this video, we are going to use technology to solve the problems. In previous videos, we have solved problems on binomial distribution probability by hand. So it is recommended you view the videos we did by hand first prior to viewing this video that we shall do with technology. So let's get started. In this particular section, we shall only use my calculator to do it because StatCrunch does not do it. StatCrunch does not do the particular questions in this section as at the time of this recording. So we are just going to use my calculator to solve the problems. Question 1. In a clinical trial of a cholesterol drug, 411 subjects were given a placebo and 13% of them developed headaches. For such randomly selected groups of 411 subjects given a placebo, identify the values of n, that's the sample size, p, the probability of success, q, the probability of failure, that would be used for finding the mean and standard deviation for the number of subjects who develop headaches. So in this case, the n, the sample size is 411. The probability of success was the percentage of people that developed headaches, which is 13%. So type an integer or a decimal. So 13% is 0.13. And then the probability of failure, that is Q, would be 100% minus 13%. That gives us 87%, right? 87%. So, which is 0.87. Okay, 0.87. Question 2. Assume that a procedure yields a binomial distribution with n trials and the probability of success for one trial is p. Use the given values of n and p to find the mean mu, that's the population mean mu, and standard deviation sigma, lowercase sigma, that is the population standard deviation, lowercase sigma. Also, use the range rule of thumb to find the minimum usual value, mu minus 2 sigma, and the maximum usual value, mu plus 2 sigma. Okay, I'm gonna, let's get my calculator, okay? So, I'm gonna go to Google. So I'm pleased to let you know that my two calculators are now mobile friendly. Okay, so my two calculators are now mobile friendly. Remember, I used to use this one. but this one now is now mobile friendly. www.samuelchukwuemeka.com. So I thank God. Yay! Okay, so you click on this, you can go to you can jump to portfolio, and we will use the probability distribution calculator. Or you can go to mathematics and then click on statistics, and in the resources we see probability distribution calculator. This is what we are going to use. So I'm gonna put this to be in the same page with this. Okay, and I need binomial. Actually, let me maximize this first. I need binomial distribution, and let me restore it. Binomial distribution probability. Binomial probability distribution. Binomial probability distribution. So we're gonna look at this, given the sample size and the probability of success, and you want to find this here. So n is 1428, p is 3/4, which is 0.75. You want to convert this to decimal always. This calculator will only work if you convert it to decimal. Okay, and you press calculate. So the mean is 1071. Okay, the standard deviation to one decimal place is 16.4. The minimum usual value to one decimal place is 1038.3, and the maximum usual value to one decimal place is 1103.7. Okay. Question 3. You can, it's the same kind of questions they asked. In an analysis of preliminary test results from a gender selection method, 41 babies are born, and it is assumed that 50% of babies are girls. So n is 41, p is 0.5. So I'm just gonna reset this. N here is 41, and if you want to clear all these, you have to just restart. You have to reload if you want to clear all those. Okay, you just refresh the page and it will clear everything. But if you want to just clear this, you press reset. So n is 41 and p is 0.5. Calculate. The mean is 20.5. The standard deviation to one decimal place is 3.2. The minimum usual value to one decimal place is 14.1. The maximum usual value to one decimal place is 26.9. Question 4. The n is 140. The p, probability of success, is 0.8. Enter. You press the enter key. Okay. The mean is 112. The standard deviation is to one decimal place is 4.7. The minimum usual value to one decimal place is 102.5. The maximum usual value to one decimal place is 121.5. 1 to 1.5. Question 6. I can refresh this page. Several psychology students are unprepared for a surprise true-false test with 12 questions, and all of the answers are guesses. A. Find the mean. Yeah, this is question 5. I'm sorry. Question 5. Several psychology students are unprepared for a surprise true-false test with 12 questions, and all of the answers are guesses. A. Find the mean and standard deviation for the number of correct answers for such students. B. Would it be unusual for a student to pass by guessing, which requires getting at least 10 correct answers? Why or why not? Okay, so what's the probability when you have the true-false test? The probability of getting a question right is 0.5. Because it's just a true-false. You have only 2 answer choices, and one is correct. The other one is incorrect. So the sample space is 2. So the probability of getting an answer correct is 1 over 2, which is 0.5. So you have 12 questions. That's the sample size. Probability of success is 0.5. So the mean is 6. The mean is 6. The standard deviation to 1 decimal place is 1.7. Would it be unusual for a student to pass by guessing? And that requires getting at least 10 correct answers. So we look at the minimum usual value and the maximum usual value. The minimum usual value is 2.535898. The maximum usual value is 9.46410. 10 correct answers is outside the range. 10 correct answers is outside the range of these values. The range of the minimum and maximum is between 2.5 correct answers and 9.5 correct answers. 10 correct answers is outside this range, so it is unusual. So we say yes because 10 is greater than the maximum usual value. So the answer is A. Question 6. A candy company claims that 18% of its plain candies are orange, and a sample of 100 such candies is randomly selected. Find the mean and standard deviation for the number of orange candies in such groups of 100. So the sample size here is 100. The probability of success is 0.18. You please always convert to decimal. In order to use this calculator, you gotta convert to decimal. 18% is 0.18. Calculate. The mean is 18. The standard deviation to 1 decimal place is 3.8. 3.8. Okay. A random sample of 100 candies contains 9 orange candies. Is this result unusual? Does it seem that the claimed rate of 18% is wrong? So we look at the minimum and maximum usual values, and it's between 10 and 25. 10.32 candies and 25.68 candies. So it's between 10 and 26 between 11 and 26 candies, like, because you can have decimals as candies. So but 9 orange candies is outside this range. 9 is lower than 10.316250, so thing. Okay, so 9 is below that, so is unusual. So we look at the options. A, yes, because 9 is within the range. No, you eliminate A. B, yes, because 9 is below the minimum usual value. Thus, the claimed rate of 18% is probably wrong. Okay? So B is the correct choice. C, 9 is not within the range. No. D, 9 is greater than the maximum value. No. So the answer is B. Okay? Question 7. A headline in a certain newspaper states that most stay at first job less than 2 years. That headline is based on an online poll of 310 college graduates. Among those polled, 74% stayed at their first full-time job less than 2 years. Complete parts A through D. A. Assuming that 50% is the true percentage of graduates who stay at their first job less than 2 years, find the mean and standard deviation of the numbers of such graduates in randomly selected groups of 310 graduates. So our sample size is 310, and here the probability of success that we are going to use is 50%, 0.5. 0.5, okay? Because they said assuming that 50% is the true percentage of graduates who stay at their first job less than 2 years. So we take 50% in this case. You calculate, the mean is 155. The standard deviation to one decimal place is 8.8. Then the number of graduates among 310 who stay at their first job less than 2 years should usually fall between, okay, the minimum, and we are asked to round to one decimal place as needed. So the minimum is 137.4 and the maximum is 172.6. Okay. Find the actual number of surveyed graduates who stayed at their first job less than 2 years. Use the range of values from part B to determine whether that number is unusual. Does the result suggest that the headline is not justified? Okay, so let's find the actual number of surveyed graduates who stayed at their first job less than 2 years. Here we're gonna use the sample size is 310. The probability of success we will use here is 0.74, 74%. Okay, so round to the nearest whole number as needed. So we're gonna use this. Let's because this is graduates, we can't have we're looking at 229.4. We're looking at 229.4, which we should round to 230. But my lab is sometimes funny. We're gonna put 230. If it says it's wrong, then we can use 229. But you know, with a human being, you can't round human being. Like we can have, 0.4 human beings. So Even if it's 229.01, we want to round it to the next human being, like, because these are surveyed graduates, they are human beings. So let's try 230 first, okay? And if it says it's wrong, then we'll just do 229. Okay, you see, that's my lab for you. That's my lab for you. Okay. Is the actual number of surveyed graduates who stayed at their first job less than 2 years unusual? So we look at 229 and we look at this here, 137.4 and 172.6. 229 is outside the range, is greater than 172.6. So it's unusual because it is outside the range of usual values found in part B. So we are going to answer, the answer is B. Okay. What does the result suggest about the headline? The headline says, if you look at the headline in the newspaper, it states that most stay at first job less than 2 years. That most of them stay at first job less than 2 years. And from what we got, actually, it's outside the range, which kind of shows, yes, that the headline is justified. This is greater than the maximum range. This is greater than the maximum value. 229 is greater than the maximum value, 172.6. So the headline is justified because most stay at first job less than 2 years. So we will say that the result suggests that the headline is justified. The statement, alumni who opted in to receive communications from the website were invited to participate in the online poll, and 310 of them completed the survey, was given as part of the description of the survey methods used. What does that statement suggest about the results? So look at this question here, alumni who opted in to receive communications from the website. So there were some alumni who did not opt in, but this alumni opted in, and the ones that opted in were invited to participate in an online poll, and 310 of them completed the survey. So the survey methods is pretty much it's not a random sampling. It's not random sampling. This is like a voluntary convenience sampling. Okay, it's like a voluntary response, so it's convenience sampling. Let's see what they have here. Since the sample of 310 respondents is a voluntary response sample, the results are very questionable. The results are not accurate. The results are very questionable. Okay. Question 8. In a clinical trial of a drug used to help subjects stop smoking, 839 subjects were treated with 1 milligram doses of the drug. That group consisted of 48 subjects who experienced nausea. The probability of nausea for subjects not receiving the treatment was 0.0146. Complete parts A through C. A. Assuming that the drug has no effect, so that the probability of nausea was 0.0146. Find the mean and standard deviation for the numbers of people in groups of 839 that can be expected to experience nausea. So in this case, they gave us the sample size is 839 and the probability of success, which in this case is the probability of nausea, is 0.0146. Enter. So the mean to 1 decimal place is 12.2. The standard deviation to 1 decimal place as needed is 3.5. 3.5. Based on the result from Part A, is it unusual to find that among 839 people, there are 48 who experience nausea? Why or why not? The minimum usual value is 5.3 and the maximum usual value is 19.2. 48 is outside the range. Okay, so it is unusual. So it is unusual because 48 is outside the range of usual values. Okay, B. C. Based on the preceding results, does nausea appear to be an adverse reaction that should be of concern to those who use the drug? Let's look at these options. A. The drug does appear to be the cause of some nausea. Since the nausea rate is still quite low, about 6%, it appears to be an adverse reaction that does not occur very often. Let's see where they got this 6% from. I'm going to pull up calculator. And if you're using this for the first time, it's usually on standard. You just change it to scientific. 48 divided by 839, and you multiply by 100, or you can do 4800 divided by 839. So that's about 6%. Okay, 4800 divided by 839. Yeah, about 6%. Let's look at the other options. B. The drug does not appear to be the cause of any nausea. C. The drug does appear to be the cause of some nausea. Since the nausea rate is quite high, about 6%, it appears to be an adverse reaction that occurs very often. C, we eliminate C. 6% is not high. Okay. The drug actually appears to be the cause of some nausea. So the correct option will be A. Question 9. A government agency has specialists who analyze the frequencies of letters of the alphabet in an attempt to decipher intercepted messages. In standard English text, a particular letter is used at a rate of 7.7%. Find the mean and standard deviation for the number of times this letter will be found on a typical page of 2100 characters. So in this case, our sample size is 2100. The probability of success is 7.7%. We convert it to decimal, it will be 0.077. Enter. So the mean is 161.7. The standard deviation to 1 decimal place is 12.2. In an intercepted message, a page of 2100 characters is found to have the letter occurring 179 times. Is this unusual? So the range is between 137.3 and 186.1. That's the range of the usual values. 179 is in between the range. Okay, 179 is in between 137 and 186. So it is not unusual, no. So you say no because 179 is within the range of usual values. Okay. Question 10. In a past election, the voter turnout was 78%. In a survey, 986 subjects were asked if they voted in the election. Find the mean and standard deviation for the numbers of voters in groups of 986. B. In the survey of 986 people, 793 said that they voted in the election. Is this result consistent with the turnout, or is this result unlikely to occur with a turnout of 78%? Why or why not? C. Based on these results, does it appear that accurate voting results can be obtained by asking voters how they acted? So let's find A first. The sample size is 986, and the voter turnout was 78%, which is 0.78. The mean to one decimal place is 769.1. The standard deviation to one decimal place is 13.0. Is the result of 793 voting in the election usual or unusual? So the range of the minimum and maximum values is between 743.1 and 795.1. So 793 is within the range, so it is not unusual, it is usual. So we say the result is usual because 793 is within the range of usual values. Does it appear that accurate voting results can be obtained by asking voters how they acted? We look at with this method, we see that 793 is within the minimum and maximum usual values. So yes, because the results indicate that 78% is a possible turnout. Okay, so it's because it's within these usual values. So yes, because the results indicate that 78% is a possible turnout. See. Question 11. If a gambler places a bet on the number 7 in roulette, he or she has a 1/38 probability of winning. A. Find the mean and standard deviation for the number of wins of gamblers who bet on the number 7 160 times. B. Would 0 wins in 160 bets be an unusually low number of wins? So in this case, the sample size is 160. The probability of success is 1 out of 38. So let's do 1 divided by 38 equal to. Now let's write this whole thing as, let's write it to at least 7 decimal places. Okay, That is 0.026315 1 2 3 4 5 6 7. Okay, 158. Some of you might ask me 1 2 3 4 5 6 7. Yeah. Some of you might ask me why 7 decimal places. Well, you want to, the more number of decimal places, the better the result. Actually, if I could copy this, I would have copied the whole thing and pasted here. 1 divided by 38. So it's always good to use as many decimal places as possible to get the actual answer. Our mean here to 1 decimal place is 4.2. Now, actually, you want to always round to a higher number of decimal places before the final answer. The best advice is do not round. That's the best advice. Do not round. But if you must round to at least 5 decimal places, more than 5 or 6 decimal places or 7 decimal places, more than the number of decimal places for the final answer rounding. Okay, so take that. Do not round intermediate calculations. Do not. But if you must do, then round to a higher, much more higher number of decimal places than the number of decimal places required for the final answer. Okay. The standard deviation to 1 decimal place is 2.0. 2.0. Would 0 wins in 160 bets be an unusually low number of wins? The range for the minimum and maximum values is between 0.2 and 8.3. So 0 is outside the range. So 0 would be unusually low. Yes, because 0 is below the minimum usual value. Okay, so it's A. Question 12. For classes of 134 students, find the mean and standard deviation for the number born on the 4th of July. Ignore leap years. B. For a class of 134 students, would 2 be an unusually high number who were born on the 4th of July? So, 134 students. What is the probability that a student was born on Independence Day? Independence Day. That's the 4th of July for United States. That is 1 out of 134, because you look at the 4th day of July occurs just once in a year, and the total number of days in a year is 365 days. They told us to ignore leap years, okay, because in a leap year it will be 366. So in a normal year it's 365 days. So the probability that a student was born on the 4th day of July, which is just 1 day out of 365 days, would be 1 out of 365. So our sample size in this case is 134, and then the probability is 1 divided by 365 equal to. So let's use this to 7 decimal places. That would be 0.0027397 1 2 3 4 5 6 7. 0.0027397. Okay. Calculate. The mean to 6 decimal places will give us 0.36711 1 2 3 4 5 6. Okay, 120. 0.3671120. Okay, the standard deviation to 6 decimal places will be 0.60507 1 2 3 4 1 2 3 4 5 7 4. Okay, 1 2 3 4 5 6 0.605074. Would 2 be an unusually high number of individuals who were born on the 4th of July? The 2 is, the minimum is negative 0.84. The maximum is 1.58. The thing is, if we round this to human beings, then 2 is just the range. Okay, 2 is just the range. So we'll say that would 2 be an unusually high number of individuals? We'll say no, because 2 is within the range of usual values. Okay, so we say C. In this case, they probably didn't round it, but that's, they probably, and like I said, you see, this is something with MATLAB, and just take note of this. I'm not going to delete this here. I'm just gonna put this video so that when you see this, you know how MATLAB works. With a human being, with human beings, we always round. Honestly, we always round, and we can't have a negative anyway. So it's between 0 and 2 people. Between 0 and 2 people. But probably from the way it's programmed, that 2 is greater than the maximum usual value. So we'll check D. But with human beings, because these are students, they are human beings, it's going to be actually between 0 and 2. We can't have a negative for human being. And, even if it's 1.1 here, with human beings, we've got to put it to 2. We can't have 1.1 human beings. But anyway, we'll check D. Okay? And it's now right. I think the rest is now it's not calculations anymore. Standard deviation is square root of NPQ. That's the standard deviation of a binomial distribution. The main goal in statistics is to interpret and understand the meaning of statistical values. The dash can be very helpful in understanding the meaning of the mean and standard deviation, and that is the range rule of thumb. Okay, because it gives us the minimum and maximum values, the minimum and maximum usual values. The mean of a binomial distribution is just n times p. Yeah, if you look at the formulas, you see these. Okay, so you save. Thank you so much for listening to this video. If you have any questions, please feel free to ask. And you have a good evening.